Let's say you're studying some type of a little hill or rock formation right over here, and you're able to figure out the dimensions. You know that from this point to this point along the base, straight along level ground is 60 meters. You know the steeper side, the steeper, I guess, surface or edge of this cliff or whatever you want to call it is 20 meters. And then the longer side here, I guess the less steep side, is 50 meters long. So you're able to measure that. But now what you want to do is use your knowledge of trigonometry given this information to figure out how steep is this side. What is the actual inclination relative to level ground? Or another way of thinking about it, what is this angle theta right over there? And I encourage you to pause the video and think about it on your own. Well, it might be ringing a bell. Well, you know three sides of a triangle, and then we want to figure out an angle. And so the thing that jumps out at my head is, well, maybe the law of cosines could be useful. And let me just write out the law of cosines before we try to apply it to this triangle right over here. So the law of cosines tells us that c squared is equal to a squared plus b squared minus 2ab times the cosine of theta. And just to remind ourselves what the a, b's, and c's are, c is the side that's opposite the angle theta. So if I were to draw an arbitrary triangle right over here, and if this is our angle theta, then this determines that C is that side, and then A and B could be either of these two sides. So A could be that one, and B could be that one, or the other way around. As you can see, A and B essentially have the same role in this formula right over here. This could be B, or this could be A. So what we want to do is somehow relate this angle. We want to figure out what theta is in our little hill example right over here. So if this is going to be theta, what is C going to be? Well, C is going to be this 20-meter side. And then we could set either one of these to be A or B. We could say that this A is 50 meters and B is 60 meters. And now we can just apply the law of cosines. So the law of cosines tells us that 20 squared is equal to A squared. So that's 50 squared plus B squared plus 60 squared minus 2 times AB, so minus 2 times 50 times 60 times 60 times the cosine of theta. Times the cosine of theta. And this works out well for us because they've given us everything. There's only one unknown. There's theta here. So let's see if we can solve for theta. So 20 squared, that is 400. 50 squared is 2,500. 60 squared is 3,600. And then 50 times 6, well, let's see, 2 times 50 is 100 times 60. This is all equal to 6,000. So let's see, if we simplify this a little bit, we're going to get 400 is equal to 2,500 plus 3,600. Let's see, that'd be 6,100. It's equal to 6,000. Let me do this in a new color. So when I add these two, I get 6,100. Did I do that right? Yeah. So it's 2,000 plus 3,000 is 5,000. 500 plus 600 is 1,100. So I get 6,100 minus 6,000 times the cosine of theta. Times the cosine of theta. And let's see, now we can subtract 6,100 from both sides. So I'm just going to subtract 6,100 from both sides so that I get closer to isolating the theta. So let's do that. So this is going to be negative 5,700. Is that right? 5,700 plus, yes, that is right. Right, because if this was the other way around, if this was 6,100 minus 400, it would be positive 5,700. All right, and then these two, of course, cancel out, and this is going to be equal to negative 6,000 times the cosine of theta. Times the cosine of theta. Now we can divide both sides by negative 6,000. By negative 6,000. Negative 6,000. And we get, and I'm just going to swap the sides. We get cosine of theta is equal to, let's see, we could divide the numerator and the denominator by essentially negative 100. So these are both going to become positive. So cosine of theta is equal to 57 over 60. And actually that can be simplified even more. 3 goes into 57. Is that 19 times? Yep. So this could be simplified. This is equal to 19 over 20. And we actually didn't have to do that simplification step because we're about to use our calculators, but that makes the math it makes it a little bit more tractable, right? 3 goes into 57, yeah, 19 times. And so now we can take the inverse cosine of both sides. So we could get theta is equal to the inverse cosine, or the arc cosine, of 19 over 20. Of 19 over 20. So let's get our calculator out and see if we get something that makes sense. So we want to do the inverse cosine of 19 over 20. 19 over 20. And we deserve a drum roll. We get 18.19 degrees. And I already verified that my calculator is in degree mode. So it gets 18.19 degrees. So if we wanted to round, this is approximately equal to 18.2 degrees if we want to round to the nearest tenth. So that's essentially gives us a sense of how steep this slope actually is.